So for today, we're going to be looking at two separate things. The first one's called multiplicity. The second one is called the fundamental theorem of algebra. All right, so multiplicity is first. So in multiplicity, one of the things we're looking at with multiplicity, we're going to explain what that is a little bit later, but before we do that, we have to set up the whole problems. That is by determining the degree of these functions that we have. Okay. Again, degree is the largest exponent on your variable. So in this case, we have f of x equals x. The degree is 1. So our degree on our problem is 1. Okay. And b, so g of x equals x minus 1. Again, the largest exponent on the x is 1. So that means our degree is also 1. All right, just because it has a minus 1 on the end of it doesn't change the degrees. Again, the degrees are just looking at exponents. In part C, okay, we have 1x each, and they all have 1s as their exponents. But if you're to multiply those two things together, x to the first times x to the first, you'd end up with x squared. And that means 2 is our degree, because it would be squared as the largest exponent. And the next problem, if we have x minus 1 times x minus 1, again, if we multiply the x's together, we'll get x squared, which again gives you 2 as your largest degree, or largest exponent, which means it is your degree. In E, we have x to the first times x minus 1 times x minus 1. When you multiply the x's together, you'll get x to the third. So the largest exponent is 3, which means that is your degree. And lastly, in F, we have x times x times x minus 1. Again, we're going to end up with x to the third, which means our degree is again 3. All right, now, what all this means for what we're doing. Our degrees kind of tells us a lot of different things about an equation and what's going on with it. Okay, if you have a first degree problem, it's a linear function. If you have a second degree, it's going to be a quadratic. And now we haven't talked about the third degree, but the third degree is going to be a cubic. Okay, and when you know the degrees, you also know the shape of the graph and kind of generally what it's going to look like. All right, and also the directionality of each end of the graph, all right, to some extent. All right, so that can tell you a lot of things. And one of the things it can also tell you is how many roots you can have, okay, for your degree of your function. Now, a root is going to be something what you're going to use with multiplicity. So multiplicity is how many times a particular number is a root for a given function. Now, roots are kind of a little bit confusing because roots are also sometimes called zeros. They're also called sometimes x-intercepts. All three of those things, roots, zeros, x-intercepts, if you want to say solutions, all those things refer to the same thing. And that is where the graph is going to cross the x-axis. Your x-intercept is also called a root or a zero. Okay, and it's basically, again, the same thing. So your graph may or may not cross the x-axis. Any place it does, that's going to be your root. Okay, so if we're looking for the zeros, so where that equation crosses the x-axis, okay, sometimes they have a different multiplicity, and let me explain as we go through this. So the zero in the functions f and g. So in f and g, so which is the first two functions we have in a and b. So if you take x and set it equal to 0 to find out where your root is, well, you got x equals 0. So that is going to be a multiplicity, or that you have one answer, sorry. You have one solution. And the next one, you have x minus 1 equals 0. We're going to add by 1, you're going to get x equals 1. Okay, so each one of these equations, they have one degree and they have one solution. Okay, so their multiplicity is just 1. Okay, now other problems are going to have multiple multiplicities, and we're going to show you what that is like as we go through these. Okay, so we're going to find the, on C through F and the top table, we're going to find the number of zeros and then what it means to have multiplicity. Okay, if we take C, we have two separate factors. We have x equals 0, and we have x minus 1 equals 0. So x equals 0 is already done. X is also going to equal 1. So they have two separate solutions in a second degree function. So we have two zeros, okay, because we have x equals 0 and x equals 1. And your multiplicity is 0 is a multiplicity of 1. Let's get rid of that part. And then we have 1 is a multiplicity of 1, okay? what that means is 0 only shows up as an answer once, and 1 shows up as an answer once. Okay, and that's going to change in part D. So we have x minus 1 as your factor, and that equals 0, and x equals 1. But there are 2 of those. Okay, so the number of zeros is, well, it only goes through the x-axis in one spot. It goes through the x-axis at one spot, which is 1. So the number of zeros is 1. But its multiplicity is you have 2 of them. So what that means is you have a multiplicity of answer 1. The multiplicity is 2, okay, because there are 2 answers at positive 1. Okay, hopefully that's kind of starts to make a little bit of sense. Okay, for E, we have x equals 0 as one of the factors and x minus 1 as the other one equals 0. So we have x equals 0 and x equals 1. So how many zeros are there? There are 3 zeros. Actually, there's 2 zeros. There's 0 and 1 are the spots where the graph's going to be crossing the x-axis. But the multiplicity, okay, at 0, the multiplicity is 1 because there's only one answer at 0. But at 1, the multiplicity is 2 because there's 2 answers at 0. Let's look at the last one. For F, we have x equals 0, and that's done twice, and x minus 1 equals 0, which x equals 1. So in the number of zeros, again, there's only 2 zeros in this case. 2 places where the x is going to cross, the graph is going to cross the x-axis. But the multiplicity is, if it's at 0, the multiplicity is 2 because there's 2 answers at 0. And for x minus 1, or x equals 1, it's going to be the multiplicity of 1. Okay? So let's look at some examples and what this would look like when you're doing these problems. Okay? Because this can be a little bit of a confusing idea. All right, let's give you some examples of just general problems and how their multiplicities would be. So we're going to make up some functions. So we have x minus 2, x minus 3 squared, and then x plus 4 cubed. Okay? So we have 3 separate factors in this. Okay? Distinct numbers. So x minus 2 equals 0, x minus 3 equals 0, and x plus 4 equals 0. So if we solve these, we're going to have positive 2, positive 3, and negative 4. Okay? So we have 3 different spots where our graph is going to cross the x-axis, but this has a multiplicity of 1 because it only happens once. Okay? Because the exponent on this, let's do this. The exponent on this is only 1. Okay? The x equals 3 has a multiplicity, I'm going to abbreviate, multiplicity of 2 because it's seen twice. And this one has a multiplicity of 3 because it has 3 as an exponent. Okay? So there are 3 different x plus 4s in your equation. So your degree is going to be 6 because there's 1x and then 2 more and then 3 more. So that's 6 total. So you're going to degree is going to be 6, and all your zeros are going to have a multiplicity, a total combined of 6. Okay, so that you kind of see how this works. Okay, let's give you one more example that goes backwards. Okay, let's say we had factors of x let's see, x minus 3, and then x minus 3 again, x minus 3 again, x minus 3 again. How would you write this in a function form so that you have a multiplicity of 4 for x minus 3 and then a multiplicity of 1 for x? Okay, how this would be, if you write a function, you'd have x and x minus 3 to the 4th power. Okay? So that's how you'd write it. So again, the factor here of x minus 3 has a multiplicity of 4 because it's highest degree. And then this has a multiplicity of 1 because it's highest degree of those factors. Okay? We'll show you some examples, or we'll have some practice problems that you can see how these kind of ideas work. But for now, we're also going to show you one other topic. This is like a kind of a short topic as well. It's called the fundamental theorem of algebra. Okay, and what that basically states is that an equation can have no more roots or zeros or x-intercepts or solutions than it has degrees. Okay, it can have less or the same but not more. Okay, let's look how this works. So basically what this is saying, what that is saying is that based on your degrees, you can have the graph can cross the x-axis that many times as your degrees or less, but never more. Okay, so our degree here is 1, and our graph crosses the x-axis once. Okay, and that works. Here, our degree is 1, and the graph crosses the x-axis in one spot. Here, our degree is 2, and the graph crosses the x-axis 2 spots because they're 2 separate distinct factors. All right. Here, our degree is 2, but it only hits the x-axis in one spot right there. Okay, so that's less than the degree, but you'll notice that that's because that the multiplicity of this function is x equals 1 is 2 spots. Okay, so it's a multiplicity of 2. So because it's got a multiplicity of 2, that means although it has 2 separate factors, they count as 1 because it's the same place. Okay. Here we have x to the third, and we have 1 and 2 spots. Okay, again, because the multiplicity of x minus 1 is 2. All right, so it could have up to 3 spots that cross the x-axis, but this one only has 2. All right, and then here you have x times x times x. You have x to the third. All right, so we have one spot where it crosses the x-axis and another spot, but that's it. So it has a degree of 3. It only has 2 spots where it crosses the x-axis. Okay. Now, again, you can have the same number or less. You can never have more. Okay. So, for example, this graph in F could never do something like this. And we'll make it red so it's a little bit more obvious. You can never do something like this, where it crosses 1, 2, 3, 4, because the degree is only 3, so that will never happen. Okay, so that'd be a no. All right, so let's look at this last examples. Okay, so we're going to use the fundamental theorem of algebra to explain why the graphs below can or cannot be represented by the equations. Okay, so the first one, we have 5 times x plus 7 times x minus 1. Okay, so what is the degree of this equation, of this function? Okay, well, if we multiplied everything out, you'd have x squared. And then how many places does the graph cross the x-axis? Let's count them up. We got 1, 2, and 3. Okay, well, that's more places that it crosses the x-axis than there is degrees. So your answer would be is, no, it cannot be. Crosses the x-axis more times than it has degrees. Okay, so again, there's an example of doesn't work because it's passing through the x-axis more times than it has degrees. Okay, let's take the next one. You have x times x minus 5. So this would be x squared again, and it crosses through the x-axis, and 2 spots here and here. So this would be yes. Okay, so it crosses x-axis in 2 degrees, or in 2 places, sorry. And degree is 2. All right, last one. So if we look at this, we have a multiplicity of 2 for x minus 1, because that exponent is 2. So if we have x x squared here, and then x, that's going to be a degree of 4. Okay, so we're looking for how many times does this cross? This crosses at 1. It hits the x-axis right there at 2, and here at 3. All right, so does this work because it doesn't match? Okay, well, it does. So this would be a yes because it crosses, oops, I spelled crosses wrong. Crosses x-axis 3 times with a degree of 4. So it can cross less. Now, one of the things I want to point out again here is because of the x minus 1 and its multiplicity of 2, right here, that's what causes this. It doesn't go through the x-axis, it bounces off of it. Okay, but it still touches the x-axis, which is why it's a solution. Okay, so that's why it's a effect of the multiplicity. All right, and the other 2 spots, here and here, because it's not multiplicity, or it doesn't have a multiplicity greater than 1, it goes through the x-axis and keeps going. All right, so those are some ideas along with multiplicity and fundamental theorem of algebra. Again, make sure when the practice comes that you try the practice and ask questions if you have questions, and get help if you need help.